So, good morning to everyone. Today, I am going to discuss one of the research paper, that is a denoising method of partial discharge signals employing wavelet kernel-aided deep learning framework. So, what are the things I have to write in the paper? That first I will let you know. So, first one, that is in the introduction part, I have written about the overview of partial discharge signals and their importance in the electrical insulation system. Next, I have written about the discussion, and I have discussed the challenges posed by the noise in the partial discharge signals and its impact on the accurate detection and the analysis. And again, in the introduction part only, I have introduced a concept of the denoising methods to enhance the quality of the partial discharge signals for the improved analysis. After that, I have done the literature's survey, that I have reviewed the existing denoising techniques for the partial discharge signals, highlighting their strengths and the limitations. I have discussed the emergence of the deep learning methods in the signal denoising and their potential for handling complex noise patterns. Next, I have introduced the concept of the wavelet kernels and their applications in the signal processing tasks. After that, I have discussed the methodology. In the methodology, in the methodology, I have described the proposed denoising methods using the wavelet kernel aided deep learning framework. I have explained the architecture of the deep learning model, including the use of the wavelet kernels as the feature extractions. Next one, I have given the detailed training process, including data pre-processing, model architecture, and the optimization algorithm. Next, I have discussed how the model is trained to effectively remove the noise from the partial discharge signals while preserving the relevant information. After that, I have given the experimental setup to specify the data set used for the training and the evaluation, including the details such as the size, sources, characteristics of the partial discharge signals. After that, I have described the hardware and the software environment used for the conducting the experiments. In the last, I have discussed the performance metrics uh, used to evaluate the denoising methods such as the signal to noise ratio, mean square error. And lastly, I have discussed the result and the conclusion part, and I have given the references. So first, let me discuss what is this title name. What does it mean? So the title itself shows that the wavelet kernel deep learning framework refers to a method that combines the principle of the wavelet transform, kernel method, and the deep learning techniques to effectively denoise the signals, particularly partial discharge signals in this research paper. So first, I want to tell you what is wavelet transform. First, we should know what is wavelet transform. Wavelet transform is a mathematical tool used to analyze the signals in both time and frequency domain. It decomposes a signal into different frequency components, allowing for the identification of the transient features and the localization of the event in the time. In this context, I have of the signal denoising, wavelet transforms are often used to separate the noise from the desired signal components. Next, that is the wavelet kernel method. What is kernel method? That we should know. Kernel method is kernel method are a class of the algorithm that operate in the high dimensional feature space defined by the kernel function. These methods are commonly used for the tasks such as the classification, regression, and clustering. In signal processing, kernel method can be applied to extract the relevant features from the signals, which can be used for the denoising or the tasks. Next one, deep learning. Deep learning is a subset of the machine learning. Machine learning that involves the use of the neural network with multiple layers. Deep learning models are capable of learning the hierarchical representation of the data, making them well suited for the tasks involving the complex patterns or the large amount of data. In signal processing, deep learning techniques uh, have a better advantage for the denoising, feature extractions, and the signal classification tasks. So in this paper that I have proposed and I want to discuss about that wavelet kernel, this refers to the combination of the wavelet transforms and the kernel method. The wavelet transform is used to extract the information from the inputs, and the kernel methods are employed to the further process these features and captures the complex patterns present in the data. Next one, so I want to discuss some points that we have discussed in the paper. Such first, what we have done, noise can contaminate the acoustic partial discharge. We have used the acoustic partial discharge signals, resulting in the inaccurate detection and the interpretation that we have to denoise. As a result, the denoising aquatic partial discharge has achieved the significant attention to enable the precise diagnostic and analysis. So in this research paper that we have used is the Wavelet Kernel-Aided deep learning framework for to denoise the partial discharge signals obtained from the high voltage power apparatus. For this work that we have used the fully convolutional neural network, fully convolutional network based autoencoder to perform the denoising operation. Unlike the classical fully convolutional network, the proposed FCN employs the mother wavelets as the convolutional neural network. So both quantitative and the qualitative assessment demonstrate the effectiveness of the proposed method when compared to the effective denoising techniques. Furthermore, the validation of the proposed method extends to do the two variations of the simulated partial discharge signals is subject to varying the level of the whiteGaussian noise. The proposed scheme can be monitored and diagnose the signal modifications in the real time. So what we have tried to do in this uh, paper, that we have taken the high voltage apparatus and the we have performed the fully convolution network based on the autoencoder to denoise the signals. So how, I will show you the overview of that one also. In the starting, I have told you that what are the things that we have taken while writing the paper is first, what is partial discharge? Partial discharge is a critical concern within the transformers and it can initiate the insulator regressions. So we have to take care of the partial discharge anywhere. This is the overview of the partial discharge signals and their importance in the electrical insulation system or the electrical high voltage or anywhere we can take the power partial discharge. Next, we have discussed the challenges posed by the noise in the partial discharge signals and their impact on the accurate detection and the analysis. So uh, this is the introduction part about the partial discharge, and we have done the literature survey also, how the paper is written. So next one, this is the overview of the proposed deep learning architecture for denoising the partial discharge signals. So first, from the apparatus, we have taken the this is the original partial discharge signals. This is the original signals. After that, we have added the different SNR to make the noisy signal. Means this is the original signal. We have added some SNR, and then that signal have been make noisy. After that, we have used the FCNA, fully convolutional network autoencoder, to denoise these particular noisy signals, and we have we have obtained this one of the this one. So this is the basic idea about this one. And after that, here the noise that we added is the white Gaussian noise, because there are different types of noises there. So here we have added the white Gaussian noise. After that, we have done the literature survey. Here also you can read these all the introduction part, and after that, this paper introduces a deep learning framework assisted by the wavelet kernel for denoising acoustic partial discharge signals, as wavelet can analyze the partial discharge signals due to their inherent feature, and the several mother wavelets are used as the convolutional filter in the deep learning framework. So this is the figure 1, illustrates the overview of the proposed method with a key highlight summarized as follows. First one, a high setup was formed in the laboratory, in the high voltage laboratory, to obtain the acoustic partial discharge signals from an emulated cubical tank. Acoustic emission sensors have been placed on the surface of the ECT. ECT stands for the emulated cubical tank, to acquire the partial discharge signals, followed by the amplification and the distillizing via the partial discharge analyzer. After that, a mother wavelet aided deep learning framework has been proposed for the denoising the partial discharge signals. Here we have used the 12 mother wavelets from the wavelet family, like the morlet, Dobbich's, Wavelet, and Simlet are used as the convolutional filters for extracting the significant features from the partial discharge signals for the necessary operation. Third one, that is the a fully convolutional neural network based autoencoder proposed to denoise the partial discharge signals. Unlike the conventional CNN residual connections are implemented in the encoder-decoder structure for the desired purposes. Next one, the fourth one, is the to assess the robustness of the proposed noise elimination scheme. A both simulated and the laboratory prepared partial discharge signals were deliberately subjected to the varying the different white Gaussian noise, spanning multiple signal to noise ratio. The results demonstrate the superior effectiveness of the proposed method compared to the convolutional techniques. So this one is the two variants of the simulated partial discharge signals. And this is the waveform of the measured partial discharge signals obtained from three acoustic sensors, where the x-axis represents the data samples. This is the data samples, that is from 0 to 2500, and y-axis represents the amplitude in the voltage. So what are the simulated and the measured partial sensors? First one, the simulated analysis of the partial discharge signals. So these equations have been taken to generate the partial discharge, to generate this one waveform, and where the estimated partial discharge signals were generated form of the transformer. So this all are the data, this is the equation taken, and these all are the data have been taken to generate the partial waveforms. And that waveform we have added some whiteGaussian noise, and then we have tried to attenuate the signals. So what are the discussion that we are looking this diagram, this diagram, and this diagram, these two and these two. So this is the setup explanation, that is the we have taken the acoustic partial discharge signals, that is the frequency range, and this is the if you will study, then you can go through this line. So this is the totally the liberty setup discussion, how we have extracted the partial discharge from the high voltage apparatus. So these all the things that we have taken, we have written here. Next one, what are the proposed method that we have used? First one, the overview autoencoder. Already I have discussed about the autoencoder, what does it mean and how it works. So autoencoder is, no, already I've discussed, okay na? Next one is the overview of the fully convolutional network. So this is the overview of the fully convolutional network. So this is the things that we have written about the in the short form overview of the convolutional network. This is our proposed wavelet kernel fully convolutional network based autoencoder. So already I have discussed about the uh, kernel method and the deep learning. Like, what is kernel? Kernel method is a class of the algorithm that operates in the high dimensional features space defined by the kernel function. Here, what try to we have done novel things in this paper, that both simulated and the acquired partial discharge signals are utilized as the input for the acoustic partial discharge signals waveforms within the wavelet aided convolutional neural network autoencoder. Here the proposed fully convolutional networks here comprises a 5-layer encoder and a 6 decoder, that is have been shown in the figure number 4. This is the figure number 4 that I am discussing there. This is the figure number 4. A proposed the primary purpose of the encoder is to reduce the dimensions of the partial discharge signals and convert them into the low dimensional features. So this encoder consists of a 5-layer, each comprises a convolutional neural network, a batch normalization BN, a layer activation layer AL. The input to the encoder can be either simulated or the measured partial discharge signals. In the first layer of the encoder, a convolutional process is applied using the 12 wavelet kernels of the size that is a 250 into 1, and the subsequent convolution layer 10, 8 and the 66, 8 and 6 wavelet kernels of the similar size 250 into 1 with the stride of the one transformation and the function. So on the other hand, decoder exhibits the inverse symmetry to the encoder. It is responsible for the reconstructing the output based on the low dimensional feature received from the encoder. So the decoder consists of the deconvolutional layer responsible for the upsampling the features. So these all are the discussion about the proposed method. So in our wavelet kernel, FC and AE model, we have utilized the exponential linear unit as the activation function for the hidden layer. Notably, no activation function is applied to the output layer. Furthermore, the normalization BN, normalization batch is employed for the hidden layer, contributing to the stabilization and acceleration of the process. So what to the discussion I have done, so about the structure of the proposed wavelet kernel method, that is fully discussed here in this paragraph. Next, what I have done, the details and the experimental results. So this is the results, data set explanation and the reprocessing. The simulated partial discharge and the measured partial discharge signals are collected from the experiments that have been discussed and I have told you in the sections 2. Very intentionally subjected to the various noise level, including the SNR -5, -10, -5, -5, 10, and the 15. So this is the denoising method. So first, what I have done in the figure 1, this is the original and the noisy signals. This is the original and the noisy signal. The black one is the original signals, and after that we have added the SNR of the 10 dB. Yes or no? So after that, we have used the empirical mode decomposition method to denoise the signals. So we got these waveforms. So the black one is the original signals and the denoised by the EMD. So we are not getting the accurate, and we are also not getting the nearby after using this method by the empirical mode decomposition method. After that, we have used the WSD, wavelet signal denoising method. So here, what whenever we use this method, so we are getting somewhat nearby to the original signals, like similar, not exactly similar. So this we are trying to get the similar to the original signals, but you can see here we are not getting nearby also. When we have used the proposed method, that is the wavelet kernel uh, method, so what we have done, we not fully, but it is 99 95 to 98 percentage it is matching to the original signals. So that's why we can say here that our proposed method is accurate and very good for to deny the signals compared to the other classical methods. Again, what we have tried to do, we have given the denoising signals with -10 dB of SNRs. So here we have added the -10 dB of SNRs. Here we have the 10 dB of SNR. So here the more noisy signals are there. Again, we have used the EMD method to denoise signals, and we have again we have tried to denoise signals with the WSD. Then this is the our proposed methods to denoise the signals. So this is the explanation about the what we have tried to done in this figure and what are the different types of scenarios that we are trying to use here. Similarly, you can see here that denoising with the 10 dB of SNR. So in the 10 dB of SNRs, the results, whatever the coming here by using the different methods to denoise signals, so it is here. So this is the comparison performance matrix by the several denoising methods are the -10 dB. This is for the -10 dB. So EMD that we have taken reference, and this is the SNR value that we are getting here. Oh, but in our methods, the SNR is getting improved, and the RC method here is the we have discussed here this one RC. First one, DSNR stands for the signal to noise ratio. It is written here. Next one, this is the RCC, that is the cross correlation. So cross correlation, when the cross correlation is near to 1, so it means that it has denoised very nicely. RMAC is the root mean square error. Next one is the RNA reduction to the noise level. So these four metrics have been used to check whether how much the signal have been denoised compared to the others method. So lastly, we have checked here that our method have been denoised properly compared to the other methods. So also here for the we have done for the minus 10 dB SNR. This is the plus 10 dB of SNR that we have compared on the performance matrix, and we have checked here that our method have been denoised properly compared to the other signals. So these all are the things that we have written here. In the conclusion, this article introduces a deep learning framework to enhance the wavelet kernels for the noise reductions in the partial discharge signals. A fully convolutional network, an autoencoder have been proposed for the necessary operations. Mother wavelets are the convolutional filters to process the partial discharge signals throughout the auto encoder decoder structure. Comprehensive experiments reveals the proposed scheme's effectiveness with the simulated and the measured partial discharge signals in the terms of the various performance metrics. The denoising scheme is generic and can be implemented for the other uh, signal modalities in any industrial systems. So these all are the references have been used while writing the paper. So whatever the methods that we have run here, it is in the MATLAB R20A, and we have written the proper code for this one to generate the noisy signals, denoise signals, and the different methods we have used here to denoise the signals. So this is the one of the best paper, and this is the good one that you can refer for the research work and for the many more. So thank you for watching my video, and if you are getting any doubt regarding this paper, so you can text in the you can send a message to me. Thank you.